Assalamualaikum and good day to sir. My name is Dayana binti Abdul. I am from Group 1 and my members' names are Farah Dina binti Muhammad KHAIRUL and NURUL HAZWANI HUSNA binti Shahrizal. Today we are going to present the mini project which is the analysis of DC to DC boost converter circuit. So I'm going to do the introduction of the mini project. As we can see here, there are 4 points need to be explained. So the first one, the boost converter is known as the step-up converter. It is a DC to DC power converter that has the output voltage is larger than the input. Second, the circuit is operating in the steady state condition. We also know the capacitor is very large and the output is held constant at voltage called as Vout. Next, the inductor current is continuous, that is always positive, and the switching period is where the switch is closed for time dt and open for time 1 minus d multiplied by t. So for our task given, we need to construct the DC to DC boost converter circuit by using the MATLAB software and have to plug in the given parameter. We also set the specific value of frequency and duty ratio. So at last, we have made the calculation to prove the value from the simulation is accurate. So this is the example of the boost converter circuit that has inductor, diode, switching device such as MOSFET, IGBT and idle switch. So and we have capacitor and load as a resistor and the voltage source. So for the simulation we use the idle switch for this mini project. So I do the part of pre-project. We know the pre-project has 3 contents, and the first content is the analysis or analyze and discuss the operations of DC to DC boost converter circuit. So the analysis is the voltage of intermediate node is equal to 0 during T on and equal to VO during T off. Hence, its mean voltage is given by V in equal to VO multiplied by 1 minus T. The current flowing through the diode is null during T on. So it has a mean value given by IL multiplied by 1 minus T. Based on the consideration, the equivalence schematic of a figure 7 can be shown as here, and by that they are a voltage dependent voltage source and current dependent current source. Thus, it can reproduce the voltage at the intermediate node and current flowing through the inductance respectively. Next, I will explain about the operation of the DC to DC boost converter circuit. So the DC to DC boost converter circuit operated or works in 2 modes, which is in switch on mode and in switch off mode. So for the mode 1, which is the switch on, we know the signal source turn into high and also the idle switching. The current is diverted through the idle switching by inductor and the capacitor stay charged since it cannot discharge through the now back bias diode. Next, the power source is not immediately shortened and the inductor make the current ramp up relatively slowly. So the magnetic fields generate around the inductor in the circuit. So for mode 2, which is switch off, the current to the inductor stops suddenly and the inductor need to maintain a smooth flow current. so it does not like a sudden changes in the current. So from that, it can respond by generating the large voltage with the opposite polarity of voltage originally that supply to it using the energy stored in the magnetic field to maintain the current flow. So this is example of the working or operated for the DC to DC boost converter circuit. As we can see here, the switch closed, so the current is only operated in the blue one. So when it's off, which is open, so all the green light can appear by here, and this is the duty cycle pulse for this circuit. So this is the second content of pre-project for the mini project. So we need to sketch the following waveform to support the discussion in A. So we know the duty cycle pulse is like this, that have closed parts and open part, and then the output voltage is in steady state condition, that always positive value, and the last one is the output current that have inductor current maximum and inductor current minimum. So that's all for the content number 2 for mini project. So the last content of the pre-project is to derive the equations for output voltage and output voltage ripple. So the output voltage, the VO, has two conditions for the switch, such as close and open. So we see the switch close conditions equation to derive. So VL equal to V in equal to L multiplied by DIL over dt. So DIL over dt equal to changes IL over changes T equal to V in. So we get the last equations is V in over L multiplied by dt. So for the switch open conditions is VL equal to V in minus VO equal to L multiplied by DIL over dt. So DIL over dt equal to changes IL over changes T equal to changes IL over 1 minus D multiplied by T. So equal to V in minus VO over L. So the last equation we get V in minus VO multiplied by 1 minus D multiplied by T over L. So we combine the both equations and we get the VO equal to V in over 1 minus D. So the output voltage ripple changes VO. We define the definitions of capacitance. So Q equal to C multiply VO. So we make it as a changes Q equal to C multiply changes VO and derive it equal to changes Q over C. So the change of charge changes Q is the area of the rectangular below the time axis. So the changes Q is equal to VO over R multiplied by dt, and at last we get the output voltage ripple equal to VO multiply dt over RC, or we use the other equations VOD over RC multiplied by frequency. I will pass to the next member to proceed the mini project.
Assalamualaikum and hi everyone. My name is Farah Dina binti Muhammad KHAIRUL. Today I will be present a little bit about the simulation characteristic that we have implement. So in our mini project, we construct the DC-DC post converter circuit. So this is a circuit that we have created where we will use the parameter setting given, and they are our own settings such as frequency and duty cycle. So the parameter we use are resistor, capacitor, inductor, input DC voltage, display, pulse generator and scope. The value for the resistor we use is 50 ohms. The value of the capacitor is 100 microfarad. Inductor is 400 microfarad, and we have also the set the best value of frequency but not less than 20 kilohertz. We use 2500 kilohertz, and the duty cycle we set 0.85 as the best duty cycle. We also use a formula to get the duty cycle reading that is almost accurate. So for simulating time, we set 2 seconds and use a DC input voltage of 50 volt. Then on the pulse generator, we set 4 exponent -7 using the formula T equal to 1 per frequency, and the pulse width we set 18.5%. Then when we set the correct and accurate value on the generator pulse, we will get a waveform like this. Next, we will run the circuit and read the value of the output voltage and output current on the inductor. In this simulation, we can get the value of the output voltage is 313.2 volt, and the output current on the inductor is 44.185 ampere. After we run the circuit, we go to the scope, and the waveform we get is the underdamped type. In the waveform, there will be a straight line where it's called steady state response. In steady state response, we can find the value of the output voltage ripple from the simulation. So the output voltage ripple value we found is 0.0225 volt. Okay, for the output current waveform, we need to measure the minimum and maximum inductor current on the steady state response. After we zoom in on the steady state response, we plot the maximum and minimum corner to get the value that is almost the same as the calculation using our own formula. In this section, the value of the minimum inductor current is 44.85 ampere, and the value of the maximum inductor current is 44.89 ampere. With the value that's been measured on the DC-DC boost converter circuit, we can also determine the measurement value with the calculation using the correct formula. It is possible that the value only change slightly, possibly due to an error during the measurement. So I left it to my friend to explain some calculation to find the output voltage ripple and maximum inductor current. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL HAZWANI HUSNA. So I will continue the explanation of calculation for result simulation. For the calculation of output voltage, we get 333.33 volt. For the simulation result, we get 322.2 volt. For the output voltage ripple, we get 0.0227 volt for the calculation. But for the simulation, we can see the result from the slide before. For the load current, we get 44.44 ampere for the calculation, and the simulation result, we get 44.85 volt. For the minimum current, we get 44.4188 for the calculation, and also for the maximum current, we get 44.4613 for the calculation also.
In conclusion, after we make a pre-project and simulation characteristic, we can explain the significance by using gate drive for converter circuit. In this circuit, we use idle switch. Next, to know and understand the DC-DC converter operating principle, let's consider the working principle of DC-DC converter. The low input voltage converter into high output DC voltage using DC-DC boost converter. The last one is we know how to analyze the boost DC-DC converter performance under variation of parameter. In this circuit we create, the converter operates in two modes, which is continuous conduction modes and discontinuous conduction modes.